Okay, I'm here.
Okay. Okay, I'm able to get you now.
I can hear you as well.
Okay. So far from what we have covered so far, how are you getting along with?
Yes, I know I'm getting there. I was even doing some revision yesterday.
Yes. Okay.
Okay.
Let me
All
just
right.
try to upload the slides so that we start.
Okay.
Yeah.
I think as we are uploading the slide,
Yes.
yesterday I came across some formulas for if you are finding the first quantiles,
Yes.
where they're saying 1/4. That one was saying, do you have you can use any of the formulas for you to any of the formulas.
Of the quartiles.
Yeah, the quartiles. I came across of one formula where it's saying if you want to find the first quartile, you can
Yes.
say 1/4, and the second quarter, we will say 1/4. That one 2/4, and 3/4. It's fine to use one of those formulas. Yes, as the third quarter, first quartile.
No, the problem that we are going to have is when you look at a quartile is not 25%.
Yes. Okay.
Yes, a quartile is not 25%. So 3/4 is not 75%. A quartile is any number slightly below 25%. So that's why we don't say if you are given 16 elements, you cannot say
yes
3/4 of the 16 elements, that is your third quartile, or no?
Okay.
Yes. That's why if you have looked at the lecture notes that the previous semester's lecturer gave, I managed to get hold of it.
Yes.
It seems very complicated.
Okay.
So, yes. So I've tried to come up with various ways of calculating a quartile and see which could be easy for a student, especially distance students who are studying on their own. So that's how I came up with
exactly.
yes, that's how I came up with that way. That's the one that I picked. I saw that to be easy. A student who is studying on his own is able to understand.
Okay.
Are you able to see anything on the screen?
Yes. Where I can measures of dispensation.
Okay. Yeah. So
dispensation is the amount of spread. Yeah.
Yeah. So we want to start looking at this topic, measures of dispersion. Others, they call it measures of variation. Here we are looking at the amount of spread, how the set of data is spread from the mean. That is what we are interested in. So if you look at the examples that are there, if you look at the examples that are there, some of the measures of dispersion is the standard deviation. We want to see how far is this data element from the mean. So if you look at the formula for the standard deviation, it is actually the formula for the variance, then find the square root.
Yes.
So basically, standard deviation is variance under the root. That's how we calculate the standard deviation. So let's look at an example. We have been given two sets of data, X and Y. If you look at data X, we have got 1, 2, 3, 4, 5. And if you look at data element Y, we have got 0, 0, 0, 5, 10. So if you add these measurements, you are going to find the same sum. The total will be the same. But the display or the arrangement of the data seems to be different. Data element which is in Y seems to start with 0, 0, 0, 0, then it has got 5 and 10. When you add this, you're going to get 15. If you look at the data in X, it begins with 1, 2, 3, 4, 5. If you add them again, you get 15. So you are likely to have the same mean, because we said mean is equal to sum of X divided by number of X, or sum of Y divided by number of Y. So if you add 1 plus 2 plus 3 plus 4 plus 5, you get 15. Then 15 divided by 5, you get 3. When you go to Y, you add them, you divide by 5, you get 3.
Yes.
So all these elements, they have got the same mean, which is 3. Okay?
Yes, I'm here.
Yes. So all you need to find is, we want to find the variance, which we are going to put under the square root for us to find the standard deviation. So when we are learning to calculate the standard deviation, we are also learning to calculate the variance. There are other ways of calculating the variance, but there you have one way of calculating the variance. All you need to do is, you are going to put up a column for X, and you are going to put up the column.
Just a minute.
Yes.
Just a minute. Let me just switch on the candle. Power is gone.
Oh, sorry. Okay.
Yeah, just what? Yeah, Zesco. Yeah, Zesco. Yes, we can continue.
Okay, thank you very much. So our first column, we put the elements that are in the X data. We put the elements there. In the second column, we put the mean, because we want to find the spread of the data element from the mean. So I want to find the difference. X, how far is it from the mean? So that's why the mean we are going to put it throughout here, so that we see this element 5, how far is it from our mean? Okay, so the third column, we are going to find the difference, which is X minus X bar, meaning the measurement X minus the mean of X. Then the fourth column, we are going to square the difference. That is X minus X bar squared. Are you there?
Yes. So we are saying the first column, those are the element of X.
Exactly.
The next column, that's the mean of X.
Exactly.
And then we need to find the X minus X, which is a mean. The X bar, that one is a mean.
Exactly.
We subtract 3 from 1. Then those are the
yes. These are the figures that we found. Then we started squaring them. In case it comes in a theory form, yes, why are we squaring the difference? We are trying to avoid finding a negative, which can end up giving us a variance of 0. So no wonder we square the difference so that we get rid of a negative. So -2, we square it to get a 4. -1, we square it to get 1. 0 we square to get 0. 1 we square to get 1. And 2 we square to get 4. So when we add these squared figures, we find the total, which is 10. So when we go back to our formula is in such a way that the formula for standard deviation will be, we have the root there, but we should find the summation. Okay? We find the sum of this X minus X bar then we square it. Then down here, what we are going to use is n minus 1. Now, what we are calculating is the standard deviation of a sample, not the standard deviation of a population. So, since this is the sample, we are going to reduce the degree of freedom by 1. Because this is not a population. So that's why when we added this summation here, it gave us a 10. Then what are we dividing with? We have got 5 samples here, which is n minus 1. We remain with 4. So our standard deviation is 10 divided by 4 under the root. Now, if we are calculating the variance could have just been 10 divided by 4. That should have been our variance. But because the standard deviation is variance under the root, we need to find the square root of the variance. That is our standard deviation. So are you able to calculate 10 divided by 4? What do you get?
Yes, 10 divided by 4.
Yes.
2.5.
2.5. That is our variance.
Yes.
So, yes, find the square root of the variance to get the standard deviation.
Okay. 1.5811.
Exactly. So our standard deviation is 1.58, which is the square root of the variance.
Yes.
That's how we calculate the standard deviation. Is it okay?
Yes, it's okay.
Yeah, that's how we do it. So for y, it's the same thing. We had to put down our y elements first. Then we bring in the mean for y and find the difference.
Y?
Yes. Y minus y bar. Then you square the answer.
Okay.
Yes.
Okay. So without squaring. So without squaring, that's a variance. That's a variance, not so.
Without finding the root.
The root, sorry.
Yes.
Without finding a root, that's the variance.
That is the variance, yes. Just divide, just divide and don't find the square root. That is your variance. Which is like for variance for y is 8 divided by 4. That is our variance. 8 divided by 4.
Okay.
Okay.
So we are saying whenever we are dealing with a population, we're supposed to say n minus 1.
No, when you are dealing with a sample.
The sample, oh, sorry.
Yes. For a sample, it is n minus 1. For a population, it is under. Okay, for a population, we are going to look at something. The next slide, we'll look at a population.
Okay.
Yes.
Okay.
So can we go to the next example?
Yes, sir.
Okay. So our next demonstration, it gives us what happens when you're dealing with a population. We use a capital letter N. And we don't subtract by 1. The reason is that when you are dealing with a population, there's no sample error. You have picked everything. But when you are dealing with a sample, you are likely to have some sampling error. That's why we reduce the degree of freedom.
Okay.
Yes. So for a standard deviation of the population, we divide by capital letter N. And the standard deviation of a population is not small letter s. It is this theta which looks like a Q.
Q.
Have you seen this one? When you see this,
yes,
this is the standard deviation for population. Then this small letter s is the standard deviation for sample.
Okay.
Yes. So down here, we are explaining why are we subtracting 1 from n when we are dealing with a sample. We are saying the reason we divide by n minus 1 instead of just an n is to ensure that S, which is the sample standard deviation, is an unbiased estimator of the standard deviation of the population. So we are dealing with samples, therefore we reduce our sample size by 1.
Okay.
Okay, are we able to move?
Yes, sir.
Okay, so our next slide looks at variance, which we have briefly considered. The variance, which is the standard deviation squared. Have you seen? So if you have got a standard deviation,
Yes.
for you to find the variance, square the standard deviation. So the formula for,
Come again?
if you are given a standard deviation,
Yes.
for you to find the variance, you square the standard deviation.
Okay.
Yes. If you are given the variance, to find the standard
Yes.
deviation, you find the square root.
Okay.
Yes.
That's the part where I was behind.
Yes. So the variance and the standard deviation, they are opposite of each other. That's why in the computation for variance, which is represented by s squared, all we need to do is the formula that we are using, remove the root, remove the square root. That's the formula for variance. So standard deviation, we put it under the root. Variance, we remove the square root. Everything remains the same. Okay? Are we able to proceed? Our next measure of variation is what is called coefficient of variation. Coefficient of variation. Okay? So, coefficient of variation is expressed as a percentage. Once you have calculated your standard deviation,
Yes, sir.
once you have calculated your standard deviation and you have calculated your mean, the coefficient of variation is a standard deviation divided by mean, multiplied by 100%. Coefficient of variation is equal to standard deviation divided by mean, multiplied by 100%. Yes.
Okay.
Yes. So if we are to go back to our example, previous example, we want to calculate our coefficient of variation for sample X. Okay? Let's find the coefficient of variation for sample X. The formula is standard deviation of sample X divided by the mean of sample X. Okay? So our standard deviation of sample X is 1.58 divided by our mean for sample X is 3. Yes. It gives us 0.52666. Multiply that by 100. What do you find?
52.6.
52.6.
52.6.
Exactly. So our coefficient of variation for sample X is 52.67. That's how we calculate coefficient of variation.
We round.
Exactly. we'll round it off. Okay. Can we move on?
Yes, sir.
Okay. So we are trying to see how do we apply this knowledge in business. Why do we calculate the coefficient of variation? So we are given an example of stock prices. We are told that there are some stocks with different coefficient of variation. So stock A has got a standard deviation of 1.62, and it has got a mean of 1.70. When we divide the standard deviation by the mean, we multiply it by 100%, we get 95%. And when we go to stock B has got a standard deviation of 11.33, and it has got a mean of 188.88. If we divide 11.33 by 188.88, multiply by 100%, we find a coefficient of variation of 5.9. So we are able to make a business decision if we are to do the investment. In which stock do we invest in? We are saying the standard deviation of B is higher than for A, but A is more volatile. So A is changing more than stock B. So you're able to make the decision in which stock can you invest your investment. Are you there?
Yes, I'm here.
Okay, so that's how we use the coefficient of variation. Okay, so there's another example there where we are trying to calculate everything. We are trying to calculate the mean, the median, the lower quartile, the mode, the range, the interquartile range, the variance, the standard deviation, and the coefficient of variation. This is a good example as we are winding up this lecture. You are given data. This data has got 10 measurements. So that is our N. So N is equal to 10. Now, this data has been arranged in order.
Okay, yes.
Okay. This data is arranged in order. Are you able to see on the screen?
Yes, I'm here.
Thank you. So let's.
Yes, I'm able to see.
Thank you. So we have arranged our data in ascending order as we learned earlier on. So we start dividing our data. We want to break this data into 4 parts. We break our data into 4 parts. So the first part is cutting where the 40 is. Have you seen? The second part is cutting here. The third part is cutting here.
Yes.
Yes. So let's first find our mean. We said mean is equal to total sample divided by number of samples. We add 0 plus 0 plus 40, everything here. We get 560. So 560 divided by n. What is our n? Our n is 10. So 560 divided by 10, it gives us 56. So our sample mean is 56.
Yes.
Okay, we can move. Let's find our median. Find our median. Our sample size,
okay.
Our sample size is an even number, which is a 10. So the median is sitting between 60 and 70. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So our median is sitting between 50 and 60. We count 1, 2, 3, 4. We count 1, 2, 3, 4. So we are here between 50 and 60. Are you able to see? Okay. So our median is between 50 and 60. Are you there? Yes.
Yes.
I'm sure you have noticed there's power cut here, but goodness, we're able to finish it because I'm using.
Yes.
Exactly. So let's find our median.
Yes.
50 plus 60 is 110. Divide by 2.
Yes, sir.
It gives us 55. So our median is 55, between 50 and 60 here.
Yes.
Okay, so let's find our mode. Mode, we said mode is the number, is the element that has got the most number. Okay, we are lucky, power is back here.
Yes, I've seen.
Yes, so when we look at 0, how many zeros do we have? We have got 2 zeros. When we look at 50s, how many 50s? We have got 2 50s. When we look at hundreds, we have got 2 hundreds. So we have got more than one mode. So mode is 0, 50, and 100. That is our mode. Okay?
Yes, sir.
Can we calculate our range? We said range,
Yes, we can.
Range is equal to highest number minus lowest number. That is range. So our highest measure in the data set is 100.
Minus the lowest number.
Exactly, which is 0. So our range is 100.
Yes.
Okay, let's find our interquartile range. Our interquartile range, we can calculate it if we calculate the upper quartile and the lower quartile. So let's go back and calculate the lower quartile. We said for you to calculate the lower quartile and the upper quartile, you break your data. So since our data is an even number, we are going to cut here between. When you cut between here, this is where your median is.
Yes.
So you put brackets on this part and you put brackets on this part. Have you seen?
Yes.
Yes. Now.
Yes.
Yes. So your lower quarter is found in the first part and your upper quarter is found in the second part. So what do? The lower quarter is the third measurement in your first part. And in your second part, the third element. Because the lower quartile is the median of the first part. That is another way of identifying the lower quartile.
Okay. Okay.
Have you seen? So here you have got how many elements? 1, 2, 3, 4, 5. What is your median? Your median is what is at the center. 1, 2, 1, 2. Your median is here. Have you seen? That is your median.
Yes.
Which is the third observation from the beginning or the third observation from the end. So that is our lower quartile. Then let's find our upper quartile. Our upper quartile is the median in the second part. 1, 2, 1, 2. Our median is here, 90, which is also a third observation from the end or from the beginning. So our interquartile range is the upper quartile, which is 90, minus the lower quartile, which is 40.